we will be examining is: a farmer's land edges up to the farm river, whose mouth empties into the Long Island Sound. Recently, due to the effects of sea level rising, especially during a full or new moons and extreme storms, the tide pushes the brackish water from the Long Island Sound up the farm river and over the banks onto the soil more regularly. His seeds are not germinating and the crops are beginning to fail. Our group will be helping the farmer find a solution to his issues and hopefully improve the germination rate of his crops in years to come.
First, we defined some terms and asked some questions about the problem presented. The first term we looked at was brackish water, which is water that's a mixture of salt water and fresh water.
What is germination? Germination is the initial part of seed growth. Germination starts with water. Water breaks the seed coat, and then the seed begins to duplicate its cells and make proteins and metabolize. After it duplicates its cells and starts to metabolize, the primary root emerges and grounds itself into the soil.
This is Long Island Sound. It consists of the eastern, central, and western basins. The farm river is in the middle of the central basin. This is Farm River, which follows the red line. First question we asked was, what is the salinity of the brackish water? The salinity of the western area of Long Island Sound is 20 feet parts per thousand. The salinity of the eastern area of the Long Island Sound is 35 parts per thousand. Since the Farm River is located in the central basin, the water should be around 29 parts per thousand, or 3% sodium chloride solution. So you'd take 100 milliliters of water and 3 grams of sodium to create a mark solution.
To better understand the salt concentration of the central basin, we're going to be putting it into a percentage, which is what we've been using for the experiment. So the salinity that we have so far that's known for the central basin is 29 parts per thousand. So we're going to put 29 over 1,000. And we're going to be converting this into a percentage, which hopefully most of you know is out of 100. And we're going to put that on X. So now we're going to cross multiply, and we're going to have 29 times 100 equals 1,000 X. Then we're going to combine like terms, and we have 2,900 equals 1,000 X. Then we'll divide by 1,000 on both sides to get X alone. Cross it out, and then we have 2.9 equals X. And that then tells us that the percent salt concentration of Long Island Sound is equivalent to 2.9%, as percents are out of 100, and X equals 2.9.
Global warming. Sea level rising is a result of global warming, causing the polar ice caps to melt. Global warming means that the Earth's climate is heating up due to increases in greenhouse gases in the atmosphere. As this is happening, the ice caps are heating up and melting, which causes the sea level to rise. As the dark, exposed water surface is expanding and the light ice caps are shrinking, more heat is being absorbed from the sun and contributes to the cycle that is global warming. This is called the runaway greenhouse effect. Global level sea rise is accelerating incrementally over time rather than increasing at a steady rate, as was previously thought, according to a new study based on 25 years of NASA and European satellite data. This acceleration, driven mainly by increased melting in Greenland and Antarctica, has the potential to double the total sea level rise projected by 2100 when compared to projections that assume a constant rate of sea level rise. If this acceleration continues, global sea level could be 26 inches higher by 2100, 65 centimeters. These increases were measured using satellite altimeter measurements since 1992, including the TOPEX Poseidon, JASON-1, JASON-2, and JASON-3 satellite missions, which have been jointly managed by multiple agencies, including NASA, Centre National d'Expandés, CNES, European Organization for the Exploitation of Meteorological Satellites, and the National Oceanic and Atmospheric Administration. The rate of sea level rise in the satellite era has risen from about 0.1 inches 2.5 millimeters, per year in the 1990s to about 1.3 inches, 3.4 millimeters per year today. The global mean sea level rise is up 3.2 with a error range of 0.4 millimeters a year.
4 aspects to our overall project or solution. 1. We will be dealing with the removal or neutralization of the original salt in the soil. 2. We will be dealing with the present flooding issues. 3. We will try to prevent further flooding issues. And 4. We will be finding the maximum amount of salt that a crop can germinate under.
One of the background questions we investigated was what made oceans salty. And the answer we found was the water cycle. Billions of years ago, sodium chloride was being dissolved out of the rocks by water running over the rocks and streams. Then the streams carried the salt over into the ocean. As the water cycle continued, the amount of salt in the oceans increased as more ran down until it became what it is today.
The first thing that we are going to do is find the threshold in which radishes can still grow. The question we will be answering is, what is the maximum amount of salt that radishes can still germinate under? The IV of our experiment is the amount of salt in the solution, and the DV is whether the seeds sprout or germinate.
Before doing the experiment, our group hypothesized what we thought would happen. If we add different amounts of salt in different solutions to the radish seeds, then the radish seeds will germinate from solutions at a 0% to 1% salt concentration, because they are less than the farm river's salinity, which is 2 to 3% salt concentration, which is where the radish seeds stop germinating.
First, gather all your materials. After you have gathered all of your materials, count out 20 radish seeds. Prior to the experiment, measure out 5 milliliters of one of the solutions that you have been given. Keep this in the graduated cylinder for later. Next, put the radish seeds on the paper towel, fold the longer side in half twice, and make sure that the seeds are somewhat scattered. Then take the paper towel square and put it into the plastic bag.
Add 5 milliliters of solution to the bag. Add 5 puffs of air into the bag with a pipette. Zip the bag completely. Leave the bag for 5 days to set to let the seeds germinate. Repeat this 3 times for 3 trials. After the 5 days, open the bags.
Our results for the project are as follows. For the 0% salt solution, all 20 of 20 seeds germinated. For the 0.5% salt solution, 19 out of 20 of the seeds germinated. For the 1% salt solution, 18 out of 20 of the seeds germinated. For the 1.5% salt solution, 10 out of 20 seeds germinated. For the 2% salt solution, 0 out of 20 seeds germinated. For the 2.5% salt solution, 0 out of 20 of the seeds germinated. And for the 3% salt solution, 0 out of 20 of the seeds germinated.
Seed banks are places where seeds of all kinds are stored to preserve genetic diversity. In Norway, there is a global seed bank that holds more than 1 million seed samples, almost 1 billion grains. This bank can withstand earthquakes, floods, nuclear strikes, and other cataclysmic events. It has been nicknamed the Doomsday Seed Vault because of this. It was built in 2008. The seeds are kept at an average temperature of negative 18 degrees to keep them in hibernation and to prevent them from germinating.
We did some further investigation into solutions for this problem. After completing our experiment, we learned that any seeds that were put in a 2, 2.5, or 3% salt solution did not germinate at all. This means that the central basin of the Long Island Sound must be between 2 and 3% salt concentration. One of our recommendations for a solution is to simply find a plant that can withstand these conditions.
One of the possible solutions we investigated was genetically modified organisms. These could possibly withstand the salt that was preventing the germination in the seed. Genetically modified organisms are organisms that have their genes crossbred or replaced with others to better the organism in certain aspects. This is commonly done with plants to deal with changes in weather, rotting, or other harmful circumstances. Another question we asked was, how can we change the genes? There are two ways to change the genes of an organism. You can, 1, take genes from one plant and insert it into another plant, which is called recombinant DNA, or 2, crossbreeding, which is when you breed two organisms with strong genes. Yet this solution is not possible due to our lack of knowledge in the subject.
One of the possible solutions to neutralize the already deposited salt in the farm is that we can add soluble calcium to the soil to neutralize the effects of the salt in hindering the germination process. The specific type of calcium needed for this is calcium sulfite dihydrate, which can help the soil maintain a healthy pH.
Solution costs. For this data, I looked up Farm River Farm and found that their farm is 13 acres and used that information for this data. The area was calculated out to be 52,609.13 square meters. The solution was adding calcium to the soil. The price of 99% pure calcium sulfate dihydrate is $920 to $1,200 per ton. If we only need 1 gram of calcium sulfate dihydrate per square meter of land, then the price would be $87.63 for 3 bags.
One way we can improve the drainage of the farm is to include a series of trenches running through the growing areas. We can dig a series of trenches and run pipes through them to assist with the already occurring water drainage.
A possible solution is to grow the crops in a raised bed. This idea includes raising the soil where the crops are growing to prevent the brackish water from reaching the dirt where the crops are growing. The raised bed would most likely be made of a water-impermeable material as to prevent the brackish water from reaching the seeds and their roots.